Hey everyone, welcome back. Today we're going to look at an introduction to linear systems. If you've completed the previous videos, linear function videos, today's lesson will be a lot easier for you. So a linear system, also known as a system of linear equations, is a collection of linear equations that use the same variables. So here we have system number 1, where we have x plus 2y equals 5 and 3x minus y equals 1 as the two equations. And we notice that there's linear. There's no squares or square root or anything like that. They are linear equations. And so here we have two of them. And so we say it's a 2 by 2. We have two equations with two variables like that. So here we can have another system where we have three equations and three variables. And so this is a 3 by 3 system. Or we could have this one, 3 by 4, like that, w, x, y, z as our variables. And you can have many sizes of systems. You can have 50 by 30, any kinds of size. And so a solution to the system is a coordinate that is a solution to every equation in that system. So for system number 1 here, we notice that 1, 2 is a solution to the system, because if you plug it into the first equation, you get 5 equals 5, which is true. If you plug it into the second equation, right, 3 times 1 minus 2, you get 1, which is what you're supposed to get. So it's true. So this is a solution to not only the first equation, but also the second one. And so we say that it's a solution to the system. And so in this course, we will solve 2 by 2 systems. And the branch of mathematics that solves larger systems is called linear algebra. And so we're going to solve systems different ways. We're going to see graphing, elimination, and by substitution. And so here are the possible solutions to a 2 by 2 system. You can have no solution, right? The lines are parallel. There is no intersection point. You could have one solution, right? This is one point that is on both of the lines, and so it creates an intersection point like that. So one solution. Or you can have two lines that are the same thing, just written differently. And so you can have two lines on top of each other, and so you have infinite amount of solutions. And so the system is called inconsistent if there's no solution. It's called consistent if there's one or infinite many solutions. If there's only one solution, we say with independent equations. And if they coincide, we say with dependent equations. Okay, so let's do a little bit of practice here. Is the system consistent or inconsistent? A, B, C, D. Go ahead and pause the video and answer that. Okay, so A, consistent, B, inconsistent, C is consistent, and D is consistent. And so this is some of the language that we use when we're talking about linear systems. Okay, practice number 2. Is the given coordinate, right here, a solution to the system? So go ahead and pause the video and answer that. Okay, we're back. So is it a solution to the system? So it means if I plug this point into the first equation, we get true. Right? We get 13 equals 13, so we're good. If we plug it into the second equation, we get 3 equals 3. And so this coordinate is a solution to both. Therefore, it is a solution to the system. B, if we plug in 1, 1, we get 3, no problem. Plug in 1, 1, and we get 4, which is not 5. And so this point is not a solution to the system because it is not a solution to the second equation. C, plug this into our first equation, we get 2, which is what we're supposed to, if it is a solution. And then we plug it into the second equation, and we get 4. and it's supposed to be 4 if it is a solution. And so we see it's a solution to both equations. Therefore, it is a solution to the system. And that's it. It's that easy. I'll see you guys in the next video.